a source of sound of frequency f is equal to and receiver are located at same point at t equals 0. The source starts receding away from receiver with constant acceleration 10 meter per second square. The speed of sound 340 meter per second. Find the oscillation or find the frequency of the wave. Registered by stationary receiver at t equal to 10 seconds after the start of motion. Okay, now some very some conditions is what he has brought it. So what is the meaning of this? Initially, there is a, you have to just understand the conditions clearly. It's a kinematics based now. No, nothing to do with the waves and sound. You know enough of concept. So initially, this is a detector. So what will happen to detector? The detector will be there only. He will not move. The detector will be fixed. This is at t equal to 0. The source will start accelerating from rest with constant acceleration from rest. No. So he's asking find the frequency of the wave registered by the stationary receiver at t equal to send after the start of motion. So when the detector will detect a wave at t equal to 10 seconds, as it is going to receive the wave. And the source will start accelerating from rest. Now when so by the time the wave is detected by detector, no, the source will be somewhere here.
Sir, receding away, no, sir.
Hmm?
Receding away. The source starts receiving.
What do you mean by receding? English medium? Hmm. What do you mean by receding? Yeah, I'm asking, what do you mean by receding? English medium, no, say grammar is very important. You can't just say like, sir, I'm good thinker. Language is very, minimum language basics are essential. Receding means moving away, no?
Okay, sir.
So this will be the thing. See now, the wave what happen will take some time to propagate some distance, no? The sound wave, or the moment it's generated will reach the detector, no? So when it is detected at t equal to 10 seconds, it is heard by the detector. The detector, the person standing here open, is going to hear at t equal to 10 seconds. Then when it should have been generated at 10, not at 10 seconds. The moment it's generated, it cannot jump here. It should propagate, no? Therefore, at 10 seconds, the sound is heard means when it should have been generated. Before 10 seconds or after 10 seconds? Anybody? If I say hello at 9 o'clock, will you receive will you hear at 9 o'clock only? After some, if you hear hello at 9 o'clock means when I would have said hello? Prior to 9 o'clock? Simple. Before 10 seconds, there's a common sense, nothing to do with any bigger idea of the physics. Before 10 seconds, so somewhere here at time t, the wave is generated. Okay, got this one. This is a time of generation. This is a time of receiving. Here the wave is received. So the source will continuously will generate. I don't think that it will generate. It will continuously generating. Now he's asking, find the frequency of the wave registered by the station receiver at t code 10 seconds. So what is the frequency of the wave received at t code 10 seconds? Apparent frequency asking. So it should have been generated somewhere here. It will be generated with frequency f. By the time it received will be f dash. Why? Because the relative motion. At 10 seconds, if I hear sound means somewhere between 0 and 10 seconds, the wave would have been generated. So what is the Doppler effect formula? The Doppler effect formula, what it says like f dash is equal to v speed of sound v by vs v plus vs. No, or let me write v plus v naught. Time being. What is v naught vs? Vs is the speed of the sound at the instant signal generated. What is VO? Speed of the sound, speed of the observer at an instant signal is received. Are you getting this one? So in this particular formula, what is Vs? Speed of sound. This is very important. Please, all of you do understand. You get plenty of application problems here. Speed of sound, speed of sound. Also, like a speed of source. Sorry, speed of source at an instant sound is generated. What is VO? Speed of observer or detector at an instant sound is detected. There's a meaning. So what is the state of observer at rest? Okay, V naught, I'll write it 0. So let's get into the calculation part. F dash is equal to V plus 0 F by V plus Vs. Y plus the source moving away. But we don't know Vs. Vs is what? The instant at which it is generated. So further this will become V plus Et, no? So we want the time at which the signal generated, T. Time at which signal is generated. How to calculate this T? So let where the source let it be at a distance x. So can we write anything? It is accelerating, no? So can we write x? It is accelerating from rest. Let's go for kinematics. A t square. Do we know acceleration s? Then how much of distance the wave should propagate to reach to move from source to detector? The same x. So what is x you should call? What is x you should call? Distance propagated by wave from source to detector. You have everything in the diagram. This particular wave, what happens should propagate, no? Will not be, it should propagate, no? So what is the distance? It'll propagate, it'll cover a distance x. Got the idea, no? So how to write, what is that x now? Shall I write speed of sound into 10 minus t? For what time the wave will propagate? At time t it is generated, at 10 seconds it is received. So for what time it was in propagation? 10 minus t into speed will give the distance propagated. So what is this 10 minus t? I should write it. Propagation time. Agreed? Agreed? Propagation time. Okay, now let's equate these two. So this will become v, or substituting this, 8t square by 2 v into 10 minus t. Okay, we know all the values. We'll solve for t, we'll get the required answer. Anybody? Quadratic equation, solve it. So what are these problems? These problems are something like the time of generation, the time of detection are different because the source or observer, there's a relative acceleration is there. If there is an accelerated motion between source and detector, things will be of this kind. I have answered. It is around 8.85 seconds, approximately. That value of t you're going to substitute, then you get the apparent frequency. 1.35 kilohertz. Okay, let me take the next one more. Similar to this.